Hi everyone. In this lecture we have to discussing about RCC estimation of the beam bars. So first problem, read carefully. Work out the quantities of steel RCC beam used over the clear span of 5.5 meters. The wall supporting the beam are 450 mm and the beam has 300 mm bearing over the wall on both sides. The size of the beam 250 mm into 550 mm. Concrete cover at the end of the bars and sides is 40 mm and top and bottom is 30 mm each. There are four items is there. Main reinforcement at bottom. So second one, main bent up bars 2, 3, 22 mm, 2 numbers. Top bar 5, 6, 16 mm dia, 2 numbers. Stirrups 8 mm at both ends, 1.5 meters, 150 mm center to center. 15 mm dia at the middle, 2.5 centimeters, 2.5 meters, 210 mm center to center spacing. So this was the question. First, calculating the RCC beam. Okay, so in this figure clearly mention the dimensions with over bearing and walls also. So first calculating the main straight bars. First one, so there are four item of works to be calculated. First one, main reinforcement bars, bottom, main bent up bars and top bar and stirrups. There are four item of works to be calculated. First one, main straight bar. So first bar. So length of the bar formula equal to clear span plus bearing minus end covers. So see the figure once. So it's calculating to the length. So this is the length of the bar. Okay. So how much of the amount of the beam length is 5.5 meters plus 2 into bearing 0.3. So 2 into 0.3 minus cover. So remove the covers. So that's why minus 2 into 0.04. So its side covers was 40 mm. It's converted into meters. That's why 0.04. So both sides kabatti 2 into 0.04. Okay. So the value was 6.02 meters. Okay. So now calculating the total length of the bar. Okay. So this length was 6.02 meters. So then hook will be added. So hook is 2 into hook. Hook 9 dia. Okay. Hook value is 9 dia. 6.02 plus 2 into dia. Main reinforcement 22 mm is converted into meters, 0.022 in 9 dia. Okay. So that's the value was 6.416 meters. Okay. Main straight bar length 6.416 meters. Next, second item of work, main bent up bars. So length of the bar already calculating. So 6.02 meters and now we calculating this height. So that's why the formula is depth of the beam minus top and bottom cover plus dia of the bar. Depth of the beam is 550 minus cover two sides, 2 into each side cover 30. So top and bottom cover is 30. 2 into 30 plus dia of the bar 22. So the value of 0.468 meters. Okay. So now calculating the total length of the main bent up bars. So length of the bar is 6.02 plus 2 into 9 dia plus 2 into hook. Okay. Hook value is plus. So the value of crank bars 2 into 0.42 D. Okay. So length of the bar 6.02 plus and 2 into hook 2 into 9 into dia, 9 dia kabatti 22 mm was given. So converted into meters 0.022 plus and 2 into 0.42 into dia of the dia was 0.468 meters. So now calculating the value 6.8091 meters. Okay. Next, another one, third one, distribution bar. So length of the bar already know that 6.02 meters, main bar total length 6.416 meters, distribution of the bar is equal to length of the bar 6.02 plus 2 into 9 dia hook. So 2 into dia of the bar 16 mm. So 16 mm converted into meters 0.016 meters. Okay. So now the value is 6.0308 meters. Okay. Next, for last item of work, stirrups. So first calculating the length of the stirrup. Okay. So stirrup formula is 2 into capital B plus capital D minus 2 into top and bottom cover minus 2 into side cover plus 2 into 12 dia. Okay. Hook dia was 12 pi in stirrups. So that's why 12 pi. Two sides is there. So that's why 2 into 12 pi. Okay. So width of the beam is 250 and depth of the beam is 550. 250 plus 550 minus 2 into 30. Cover both sides top and bottom 2 into 30 minus 2 into side covers 2 into 40 plus 2 into 12 into dia of the stirrup was given in 8 mm at the bottom. Okay. So both ends, so 8 mm dia, so that's why 8 mm, so all are in mm only, that's why entering mm value 2 into 12 into 8. So now the value was 1.512 mm. So 1512 mm, it's converted into meters, 1.512 meters. Okay. So the length of the stirrup is 1.512 meters. So now calculating the number of the stirrups. Okay. Number of the stirrups at one end. So everyone is separately. Okay. The one end is 15. Value is spacing 1.5 meters. So the length is 1.5 meter divided by spacing of the sides, ends, both ends 150 mm center to center. So that's why 1500 divided by, so 150 plus 1. So the number of the stirrups at one end 11 numbers, and another end also same 1.5 meters divided by 150. So 1.5 is a meter, so converted into mm. So that's why 1500 mm divided by spacing 150 mm center to center. So the value of 11 numbers. So both sides was 11 plus 11, 22 numbers. Okay. Next, number of the stirrups at middle. So middle spacing length was 2.5 meters in the question. Clearly mention the figure 2.5 meters. 2.5 meters converted into mm. 2500 divided by spacing was 210 center to center spacing. So 210 center to center spacing. So 2500 divided by 210 minus 1. So it's the middle portion was minus 1 formula. So that's why the value was 11 numbers. So both are same. At the ends was 11 numbers and middle portion was 11 numbers. So total number of the stirrups 11 plus 11 plus 11, and both ends, each end was 11 and middle portion was 11. So 11 plus 11 plus 11. So total number of the stirrups is 33 numbers. And first, so it's clearly mentioned the schedule of the bars for RCC beam. Okay. So first draw the table, serial number, description of the bar, shape of the bending, dia, numbers, length, total length, weight and total weight kgs. So first item of work, main straight bar. So he clearly mentioned the figure bar bending shape. So that's why, so bottom bar it's look like that. So dia of the bar 22 mm dia in the question was given already. So number of the bars are 2. So that's why number of the bars 2. So length 4.6 meters. So that's why mention the 6.416 meters. So total length 2 numbers into length. 2 into 6.416, it's the length was total length 12.832 meters. So next, weight of the bar. Weight of the bar formula equal to d square divided by 162 formula. So the formula was d square divided by 162. So dia of the bar 22. So 22 square divided by 162. So the weight of the bar 2.98 meters. 2.98 kgs per meter. So total weight total length 12.832 into 2.98. So the total weight was 38.23 kgs. Okay. Next item of work, second serial number 2 and main bent up bars. The shape was its bending shape. So it's look like that. So dia of the bar 22 already given in the question and numbers also given already given in the question. So 22 mm dia and numbers 2 numbers. So length of the bar bent up bar 6.809. So the value is 6.809. So total length 2 numbers into length. So 2 into 6.809. So the length was 13.618 meters. The weight already calculating in the above main straight bar. So that's why same. So d square divided by 162. So same dia was given in the both main straight bars and main bent up bars. That's why. So another one to calculating. So 22 square divided by 162. So same value 2.98. So total weight 2 into dias was different, that's why. So both are separately. So first middle portion 8 mm dia. So length of the bar, number of the bars, both sides 11 plus 11 22. So in the 22 and length of the bar 1.512 and 22 into 1.512. So calculating that value was 30.89. So next weight of the bar 8 square divided by 162 0.69 kgs. So total length 30.89 into 0.69. So now the value was 17.36. So next middle portion 16 mm dia of the bar. So bars 11 and total length 1.52 and 11 into 5 11 into 1.512. So total length was 11.83. Okay. So the weight was same 0.69, 11.83 into 0.39. So total calculating the total kgs. So 118.24 kgs total. Okay. So in this problem 3 different dias was there. 22 mm dia, 16 mm dia and 8 mm dia. So all dias are added to. So 22 mm dia. So 38.25 plus 40.86. So that the weight of the total 78.98 meters. Okay. Next 16 mm dia of the bar weight. So 16 both here and here. So 11.93 plus 19.93. So the value was 40.83. So next last one 8 number of dias. So 8 number of dias it's like 11.53. So that's why all dias are separate and weights was the separate. So thanks for watching.